Okay, now example 3, we got a fraction to a power times another fraction to a power. What I can do on this one is make one, or first of all I'm going to write the problem down as it's written. So I'm going to write down on my paper x squared y to the negative second over 3 to the first, m to the fourth, k to the first, all to the negative second power, being multiplied by y to the negative second, m to the first, over x to the third, k to the first, squared. Okay. I get a lot of students in Algebra 1, they don't want to put the first powers on there. Okay, and sometimes they get them right, sometimes they get them wrong. Most people put the ones on there, get them right more often than not. I recommend doing it till you get to the point where you're so accustomed to what you're supposed to do that it's just becomes second nature to you and you're fine. But I do recommend when you copy the problem off the board or off your book onto your paper, put 1 powers everywhere that powers are missing. Just to remind yourself that we have a base raised to a power for these rules. So each of these is objects raised to powers. What I'm going to do is I'm going to make one big fraction bar. Okay? And I'm going to deal with these separately. Let me just ungroup this. Everything that's going to be red comes from the first one. Everything that's going to be blue is going to come from the second one, just so you can see where things are coming from. So the bases of the red are x and y and 3 and m and k. And they're right where they belong. X and y on top, 3m and k on the bottom. They're all being raised to negative second power, so their original power gets multiplied by negative 2 to make the new power. 2 times negative 2 is negative 4 for x. Negative 2 times negative 2 is positive 4 for y. 1 times negative 2 is negative 2 for 3. 4 times negative 2 is negative 8 for m. And 1 times negative 2 is negative 2 for k. Everything inside the red parentheses is all being raised to the negative second power, so every power gets multiplied by negative 2. Signs change, numbers don't. Inside the blue parentheses, I got y on top, m on top, x on the bottom, k on the bottom. And all these are being raised to the second power, so every one of their powers double. For y, negative 2 times 2 is negative 4. For m, 1 times 2 is 2. For x, 3 times 2 is 6. And for k, 1 times 2 is 2. So again, make one big fraction bar of the whole thing. And that's allowed, and it just makes life easier. You don't have to deal with this fraction times that fraction, think that weird things are going on. All right? That's what we have. That's all step 1 is or ever will be. If you see a parentheses to a power, make it go away applying the rule. Step 2, negative powers must be moved. All 5 of those guys have negative powers. The other 4 do not have negative powers. So what's staying where it's at is I'm going to write in black. So I've got an m squared and a y to the 4th staying on top. I've got an x to the 6th and k squared staying on the bottom. Again, it doesn't matter where they go in position on the top or bottom, just as long as they're on the top and bottom. So these 2 positive powers staying on top, these two positive powers staying on the bottom. The 5 green things are moving. I like my numbers in front, so when I move 3 to the second power up, I'm going to put that in front. Then I got an m to the 8th and a k squared, but also moving up. On the bottom, I'm moving an x to the 4th and a y to the 4th down. So the stuff in green all moved up. The stuff in black stayed right where it was. Once I moved everything in green where it belonged, the powers became positive. These 3 bottom negative powers became positive on top. These 2 top negative powers became positive on the bottom. Okay? So that's step 3 done. Step 4, that's where we evaluate. So we're going to evaluate the number. We're also going to deal with common letters. On top I got a common m. On the bottom I have a common x. And that's it, right? I also have common k's and common y's, but that's division. We're worried about multiplication in step 4. So take it one little thing at a time. So if I evaluate 3 squared, that equals 9. If I'm multiplying m's, I'm going to add powers. 2 plus 8 is 10. And I've got y to the 4th and k squared, which isn't changing. On the bottom, I've got x to the 6th and x to the 4th makes x to the 10th. And I've got a k squared and y to the 4th that nothing's happening to. All right? Final step is division, and we divide to the extent we can. What we're looking for is the same letter on top and bottom. If we see that, we have to divide it. I have a y to the 4th on top, a y to the 4th on the bottom. The rule says, number 1, put the answer where the bigger power is, and then subtract. In this specific case, if we have exactly the same power, they cancel. And the same thing happens with the k's. K squared, exactly the same, they cancel. If this were k cubed and that were k squared, k belongs on top to the first power. So again, if we have different powers, just put the answer where the bigger power is, subtract what the power is. Everything else, m, x, and 9 are different types of things. Nothing happens to them. So 9m to the 10th over x to the 10th is the final best answer to that problem. You have to be able to multiply. You have to be able to identify negative numbers and put them where they belong. You have to be able to evaluate powers. That's probably the hardest part. 7 to the 3rd power, 343. That's kind of hard. 8 to the 9th power, I don't even want to do that one. All right. But if you have some number to a power, you might have to use a calculator for that. Adding powers, subtracting powers, canceling things that are the same. Nothing in those techniques is difficult. Just take it one piece at a time. Practice the technique, get good at it. This is my 23rd year of teaching. I've been using this technique for the last 21. I came up with my 2nd year teaching. It's the easiest way to do it. I promise you there's no other way to do it. It's easier. There's other ways to do it, but they're more complicated. So this is the most efficient way I'd recommend it.